Hello student, I am Dr. Yogesh Nana Indulkar, Assistant Professor in Chemistry. In this lecture, we will learn the most important phenomena, that is photoelectric effect. So this phenomena is crucial to understand the nature of light and to learn the quantum mechanics. So from this effect, basically it start to learn the quantum mechanics. Okay. So photoelectric effect was first observed by Heinrich Hertz in 1887. So that time basically the electromagnetic nature or wave nature of the light is already confirmed, and while studying the experiment by this Heinrich Hertz, he just discovered that the UV light which causes the emission of electron from the surface of metal. Okay. So he just said that this effect becomes the photoelectric effect because the light is utilized, this light is going to fall on the surface of the metal and electron is going to emit it. So that effect he considered as a photoelectric effect because due to the radiation electron is going to ejected. Okay. So whatever the ejected electron is there, he considered as that electron becomes the photoelectron, and whatever the radiation he used, that is the UV light. Okay. So based on that he reported the photoelectric effect. So what is photoelectric effect? Photoelectric effect is the ejection of electron from the surface of metal by radiation. Okay. So he termed as it is photoelectric effect. Now where it is used? So it is used at many places. Okay. For example, we know in the lift door people are not going to crush out. Why? Because due to utilization of this photoelectric effect. So we have to learn this one in details. Okay. So the photoelectric effects occurs when light incident on the certain metallic surface causes the electron to be ejected. So if the electron is going to ejected, then only we can say the photoelectric effect is there. If the electron is not going to ejected, that means you can't say the photoelectric effect. So we know the emitted electron becomes photoelectrons, and that electron is the same as a other electrons. It's nothing else, just it is emitted from the surface of metal. That's why we are going to say it's a photoelectron. Why it is emitted? Because of the radiation. So radiation means the photo. Okay. So this is the photoelectric effect. Photoelectric effect means the ejection of electron from the surface of metal by radiation. So if you want to study the details of these photoelectric effects, we have to learn the experimental setup. So it has the simple experimental setup. What is the experimental setup? See here, it consists of an evacuated tube having facility to enter the radiation in it. Okay. Now the metal which is we are going to use as a cathode here, which one is the clear surface, okay, clean surface metal, for which we are going to learn the photoelectric effect. Metal is we are going to use here. Then we have the collector, that is the anode, where the electron comes from that metal to here. Then that circuit is completed with the help of battery, and we have the ammeter to see the current. Okay. That simple experimental setup is there to learn the photoelectric effect. When the radiation fall here, electron is going to emitted, that electron is collected here, that means circuit is going to completed, you will get the current. Unless you are not getting the current, you can say there is no photoelectric effect. Now these photoelectric effect were studied by using these two parameters. First one, if you have to change the frequency or wavelength of the radiation, then you can learn whatever the effects are observing. Then the second one is the intensity of that radiation. So these two parameters were studied to see the photoelectric effect. For example, if you have the K, that is the potassium metal here, then if you use the red light, okay, if you use the red light, then there is no current. That means the electron is not going to ejected, it is not going to collected here, circuit is not complete, you will not get current here. Now instead of the red light, if you use the yellow light, because we know the red light having the less energy than the yellow light. So if you use the yellow light, its energy is higher, then the electron is going to ejected from this metal, circuit is completed, you will get the current here. Okay, so what observations is there? Red light, no current; yellow light, you will get the current in case of the potassium metal. Now intensity increases. If you increase the intensity, you have the yellow light. If you increase the intensity, then the current is going to increases. That means ejected electron increases. If you are increase the electron, that means current becomes the higher one. So that one you will get from the intensity. So we studied these two parameters for studying the photoelectric effect. Now what observations basically see here? For a particular metal and a given color of light, for example you have the blue light, then it is found that electron comes out with a well defined speed. Okay, electrons are ejected from the surface of metal and it has very good speed. Now that the number of electron that comes out depends on the intensity of light. Okay, if you increase the intensity, then you will get the higher current. Okay, but if you have the same radiation, okay, same blue radiation, then if you increase the intensity, you will get the current. But if you take the higher energy or higher frequency of the radiation, it will increase the speed of that electron. Okay, so these are the observations. See here, if the intensity of light increase, more electrons comes out from that surface, and if the color of the light is changes to red, that means if you decrease the energy of that radiation or frequency of the radiation, that means if you shifted from blue to red, the electron speed is slower. Okay, so speed of the electron is depends on what type of radiation you are going to use, and the number of electron is depends on how intensity of that radiation you are going to use. Okay, for the red enough light, electrons are not comes from the surface, you are not getting the current. Okay, so these observations are tabulated here. So we will see the observations of photoelectric effect experiment. So that first observation is photoelectric effect is the instant ejected of electron. That means as soon as the radiation is fall on the surface, immediately you will get the current. So that is the first observation of photoelectric effect. That is incident radiation, you will get the current. Then the second one, the incident radiation must have the threshold frequency to eject the electron from the particular metal. Now what do you mean by threshold frequency? Threshold frequency means the minimum frequency required to eject the electron. Okay, so for a particular metal, it has the fixed threshold frequency. If you use the frequency less than that nu zero, electrons are not going to ejected. If the frequency is greater than that nu zero, electrons are going to ejected. And this threshold frequency is the characteristics of the metal. That means different metal having different threshold frequency. Okay, for sodium, yeah, it has some threshold frequency. For potassium, it has different threshold frequency. Okay, so this was third observation. Then the fourth one, kinetic energy of ejected electron is directly proportional to the frequency of the radiation. If you want to increase the kinetic energy, then that is directly proportional to frequency. That means if you increase the frequency, kinetic energy of that ejected electron is going to ejected. So current is not going to change. Current is constant. Okay, you are just emitting, the number of electrons are the same, but the speed is going to increases if you increase the frequency of the radiation. But the next observation is the number of electron ejected depends on the intensity of the radiation. Now if you want to increase the intensity of the radiation, it will eject the many electron instead of few electrons. Okay, so intensity increases, current increases because number of electrons are going to ejected. So kinetic energy is depends on frequency of the radiation, and the number of electrons ejected is depends on intensity of the radiation. So this is the observations. We know that kinetic energy is calculated from the stopping potential. Stopping potential means how much potential is required to stop the electron to goes from the one place to other place. Okay, so these are the observations of photoelectric effect. Now these effect, if you want to explain with the help of classical mechanics, then what will happen? Just here. So Henry Hertz used the classical mechanics to study this photoelectric effect. What is effect? Ejection of electron from the surface of metal by radiation. So according to classical mechanics, electromagnetic radiation is an electric field that is the oscillating to its direction of the propagation. So whatever the oscillation is there, the intensity of the radiation is proportional to that amplitude. If you have the higher amplitude, then you can say it has the high energy, because energy is directly proportional to here intensity. So intensity you will get from that amplitude. So according to classical mechanics, intensity is directly proportional to energy. Okay, that means the electron from the surface of the metal, if you want to eject the electron from that surface metal, what will happen? You can eject by using any radiation, okay, any frequency radiation. Instead, only you have to increase the intensity of the radiation. If you increase the intensity of the radiation, then electron should be ejected. But experimentally prove that if you increase the intensity of the radiation and the frequency of the radiation is less than nu zero, then electrons are not going to ejected. Only electrons are ejected if nu is greater than nu zero, greater than threshold frequency, then only electrons are going to ejected. So you can say the classical mechanics is failed to explain the photoelectric effect. Then Einstein explained this photoelectric effect. So what Einstein considered? So in 1905, Einstein explained this effect by considering the particle nature of light. According to Henry Hertz, he considered the wave nature of light. But according to consider the particle nature of light, that means the light becomes the collection of particles known as the quanta, okay, or photons, and its energy becomes h nu. If you use that radiation, then kinetic energy of the ejected electron is equal to the incident photon energy minus work function. Work function basically becomes the amount of energy required to eject the electron from the surface. Okay, this is based on the conservation of energy. So this work function is again the characteristics of the metal. That means different metals have different work function, different energies required to eject the electron from that surface. So minimum frequency is required, that is the threshold frequency. So work function becomes basically h nu zero. Now according to conservations of energy, kinetic energy becomes half mv square is equal to h nu minus phi. Okay, so this energy is required to eject the electron, and whatever the remaining energy they utilize for the kinetic energy. Who explained this? Explained by the Einstein. So Einstein equation is this one, Einstein equation or photoelectric equation, that is kinetic energy is equal to h nu minus phi or h nu minus h nu zero. So according to Einstein, if h nu is greater than phi, then only electrons are going to ejected, and whatever the remaining energy is utilized for the kinetic energy. If that nu is less than nu zero, electrons are not going to ejected. If you plot this one, you will have this plot, that is kinetic versus kinetic energy versus nu, and up to nu zero electrons are not going to ejected. That means no mention about the kinetic energy. So up to nu after nu zero, you have, if you increase the nu, kinetic energy of that ejected electron increases. So whatever he explained by considering the light as a particles, okay, he explains successfully that photoelectric effect. Okay, so we can say it's a successful explanation of photoelectric effect by considering the nature of light becomes a particles. Thank you.